14 hours ago, something happened in deep space that should not be possible. On February 23, 2026, at exactly 8:42 UTC, the Space Telescope Science Institute in Baltimore received a data packet from the James Webb Space Telescope that did not show noise, corruption, or static. It showed nothing. For 40 minutes and 12 seconds, while the most advanced telescope ever built was locked onto the trajectory of 3I Atlas, the data buffer was completely empty. The antenna connection was stable. Power levels were normal. Every system reported nominal performance. And yet, 2,412 seconds of observation were gone, not damaged, not distorted, removed. In astrophysics, data errors leave fingerprints. Cosmic rays create spikes. Hardware failures produce jagged graphs. Software glitches generate scrambled code. This event produced silence, a perfect digital void inserted into a continuous stream. The statistical probability of a random cosmic ray striking at that exact moment, deleting precisely 2,412 seconds without triggering a single safety protocol, is roughly 1 in 8.4 billion. You are more likely to be struck by lightning while winning the lottery than to witness that sequence of events occur naturally. NASA engineers first assumed a software malfunction. They rebooted the solid-state recorder. They checked redundant logs. They searched for memory faults. But when they compared the timestamp with data from the European Space Agency's Gaia Observatory, the explanation collapsed. At the exact same second Webb went dark, Gaia, operating independently in a different region of space, recorded a no-value anomaly in the same sector of the sky. 2 telescopes, 2 locations, 2 separate systems, both blind at 8:42 UTC. This was not a simple malfunction. At that moment, the coordinates of 3I Atlas during the blackout became officially unknown. And that is what forces us to confront a deeper question. In decades of observing black holes that consume light and pulsars that distort signals, we have never seen a celestial object that appears to interfere with observation itself. 3I Atlas did not merely evade detection, it coincided with the erasure of its own record. To understand the weight of that claim, we have to examine what Webb was seeing before the screen went black. For 72 hours, the near-infrared camera tracked 3I Atlas at a distance of 240 million kilometers from Earth. The object traveled at 87 kilometers per second. Data was stable. Outgassing of carbon monoxide and water vapor appeared consistent with an interstellar body. Everything followed expectation. Then, at 8:35 UTC, 7 minutes before the blackout, the pattern changed. Sensors detected an instantaneous thermal spike. The surface temperature jumped from minus 140 degrees Celsius to plus 220 degrees in under 4 seconds. There was no gradual warming, no solar flare, no visible collision. Imagine a block of ice in deep space becoming hotter than an oven without any external heat source. Thermodynamics does not allow that. At 8:41 UTC, exactly 60 seconds before the wipe, the mid-infrared instrument detected something equally unusual. The object, which had been tumbling randomly like a typical asteroid, suddenly stabilized. Its rotation stopped. Its axis aligned directly toward the L2 point, the precise location of the James Webb Space Telescope. Rocks do not lock onto observers. Comets do not halt rotation without expelling massive material, and no such expulsion was recorded. Then at 8:42 UTC, the buffer overflow occurred. The sensors were overwhelmed by a signal intensity 40,000 times above calibration limits. The system purged the data to protect itself. The telescope did not power down. It defended itself. And that is when the silence began. And that silence is where the situation becomes impossible to ignore. Because when a telescope protects itself from overload, it usually logs the source clearly. This time, the purge was triggered by an input so intense that it flooded the system beyond measurable range. It was not a gradual surge, it was a directed burst. While Webb's high-gain antenna struggled to process the signal, NASA's Deep Space Network, specifically the DSS 4-3 antenna in Canberra, Australia, registered a powerful spike in the same sector. At the same second, the European Space Agency's Gaia mission logged a photometric anomaly. Meanwhile, the Atacama Large Millimeter Array in Chile recorded a phase disruption in the object's atmosphere. 3 independent systems, 3 different detection methods, 1 synchronized event. In science, independent confirmation separates theory from fact. A single instrument can fail. Multiple instruments failing simultaneously in different locations under different conditions is statistically extraordinary. The data points converge on one conclusion. Something happened at 8:42 UTC that was neither random nor mechanical. When researchers examined the final milliseconds before the buffer purge, they noticed a pattern. Natural events are chaotic. Explosions scatter debris. Collisions create irregular signatures, but this thermal spike was uniform across the surface. The rotational halt was precise, within 0.02 degrees. Stopping a 3 billion-ton object instantly requires balanced force. Apply uneven pressure, and it fractures. 3I Atlas did not fragment. It stabilized, aligned, and then emitted a burst powerful enough to blind our instruments. For 2,412 seconds, engineers in Baltimore attempted to regain control. Reset commands were sent. Buffer bypass procedures were initiated. Yet the telescope remained locked in defensive mode. When systems recovered at 9:22 UTC, 3I Atlas was still visible but altered. The thermal anomaly had vanished. Rotation resumed at a new rate. The object appeared normal again, as if the previous 40 minutes had never occurred. But orbital calculations told a different story. During the blackout, 3I Atlas shifted position by 4,200 kilometers from its predicted path. In orbital mechanics, deviations of that magnitude demand force. Gravity from Jupiter? None detected. Solar radiation pressure? Insufficient. To move an object of that mass in that time frame requires acceleration of approximately 3.4 Gs. Ice and rock cannot withstand sustained thrust at that level without structural failure. Yet, the object remained intact. That displacement occurred precisely during the window when observation was disabled. Imagine watching a vehicle travel in a straight lane. You blink. When your eyes open, it occupies the next lane without visible steering. That is the displacement scientists now face. A measurable change without visible mechanism, and then came the signal analysis. From the few surviving milliseconds before overload, engineers extracted residual data. When decomposed into component frequencies, the signal was not broadband chaos, it was narrowband, focused, centered at 22.2 GHz, the exact absorption line of water vapor. In deep space, this frequency is naturally quiet because water molecules absorb it. If one wanted to transmit a burst discretely against cosmic background noise, 22.2 GHz would be an optimal choice. Nature does not optimize for stealth, intelligence does. The pulse was directional. Data from the Deep Space Network confirms the beam was aimed within 0.004 degrees of the James Webb Space Telescope's coordinates at L2. The statistical probability of a random cometary emission achieving that alignment is effectively zero. We are left with two explanations. Either we have discovered new physics in which comets generate coherent microwave beams with precise directionality and timing, or we are observing technology. And if it is technology, then the 40-minute blackout was not an accident, it was a response. If the blackout was a response, then the sequence before it becomes even more important. The stabilization of rotation, the axis alignment toward L2, and the 22.2 GHz pulse were not isolated anomalies. They form a chain of coordinated events. The object stopped, tumbling, aimed, transmitted, and shifted trajectory, all within minutes. That pattern implies awareness of observation. During the blackout, while Webb's main systems were offline, one instrument continued operating quietly, the fine guidance sensor. The FGS is not designed for imaging. It maintains pointing accuracy by tracking subtle positional shifts. It operates on low bandwidth and was not affected by the overload. At 8:56 UTC, in the center of the data gap, the FGS logged microvibrations. At first glance, they appeared mechanical, but frequency analysis revealed modulation. The vibrations alternated in a consistent binary pattern, on, off, on, off. The carrier frequency measured 1,420 MHz, the hydrogen line. For decades, SETI researchers have identified 1,420 MHz as a logical interstellar communication frequency because hydrogen is universal. It is the most abundant element in the cosmos. Any civilization with basic physics knowledge would recognize it. During the blackout, 3I Atlas emitted a directed microwave pulse at 22.2 GHz while simultaneously generating modulated vibrations at 1,420 MHz. Two fundamental frequencies, two coordinated channels. When decoded, the binary pattern translated into prime numbers 2, 3, 5, 7, 11, 13. The sequence repeated 33 times within the 40-minute window. Prime numbers are not products of geology. They are mathematical constructs. They represent pattern recognition beyond natural processes. Consider the analogy carefully. If you entered a forest and heard rhythmic taps forming prime numbers, you would not attribute it to wind. You would infer intention. The moment Webb regained full function at 9:22 UTC, the vibrations ceased instantly. The hydrogen line modulation stopped. The second observation resumed. That timing suggests responsiveness in real time. From the vibration amplitude and gravitational interaction measured by onboard gyroscopes, engineers estimated density. The calculated mass distribution did not match porous ice. It did not match typical rocky asteroid composition. The density approximated osmium, one of the densest naturally occurring elements. A body composed primarily of osmium at that scale would not form through standard cometary accretion. It would require extreme stellar processes to concentrate heavy metals in that configuration. Yet spectral readings before the blackout showed carbon, hydrogen, and oxygen elements consistent with cometary surfaces. Surface composition suggests one thing, structural behavior suggests another. An object that appears like ice but accelerates like engineered metal. An object that emits targeted frequencies only when observed. An object that changes course when cameras are active. After the 4,200-kilometer deviation, updated orbital simulations revealed another critical development. Prior to the shift, 3I Atlas was on a hyperbolic trajectory, meaning it would pass through our solar system and leave permanently. After the blackout maneuver, its new orbit became elliptical. It effectively slowed itself down. It captured itself within the sun's gravitational influence. The recalculated perihelion is now 1.01 astronomical units, nearly identical to Earth's orbital distance from the Sunday. An interstellar object entered, reacted to observation, altered course, and positioned itself near our orbital path. Coincidence becomes increasingly difficult to defend. If this is natural, it represents unprecedented physics. If it is not natural, it represents deliberate placement. And the timeline continues forward. The shift to an elliptical orbit changed everything. Before the maneuver, 3I Atlas was a visitor. After it, the object became a resident. Orbital capture without a significant gravitational assist demands propulsion. There was no planetary flyby, no measurable slingshot from Jupiter. The acceleration required to reshape the trajectory occurred during the exact window when observation was disabled. That correlation is central to the analysis. Orbital simulations now show the object decelerating gradually, not escaping but settling into a repeating path around the Sunday. Its closest approach aligns within 1% of Earth's orbital radius. Statistically, random interstellar visitors do not fine-tune perihelion distances to match planetary orbits. Hyperbolic trajectories are typical. Capture is rare. Meanwhile, the signal profile has evolved. The Deep Space Network continues to monitor emissions. The original prime number sequence has transitioned into a geometric progression. The pattern expands logarithmically, suggesting structured transmission rather than sporadic bursts. The intervals between pulses shorten predictably as the object approaches perihelion. This raises a critical question. Is the signal strengthening as distance decreases, or is it calibrating based on our detection capability? When Webb resumed tracking, no additional thermal spikes were recorded. Rotation appears stable, though at a slightly altered rate compared to pre-blackout measurements. Spectral readings remain superficially comet-like. Outgassing continues at low levels. Surface albedo shows minimal variation. To a casual observer, it resembles any other interstellar object. Yet the timing of every anomaly aligns with observation intensity. When instruments focus, anomalies occur. When observation ceases, emissions stabilize. That feedback loop implies interaction. Consider the energy requirements. Producing a 22.2 GHz directed microwave burst powerful enough to overload Webb sensors from 240 million kilometers demands enormous output. Even advanced terrestrial transmitters would struggle to achieve comparable coherence at that range. If the emission originated from internal power, the energy source must be significant. No visible exhaust plume was detected during trajectory shift, no debris field, no fragmentation. The object retained integrity. That consistency supports the density estimates derived from gyroscopic readings. A structure capable of withstanding 3.4 Gs of sustained acceleration without disintegration is not porous ice. Engineers continue to examine buffer logs for overlooked fragments. Most of the 40-minute gap remains empty. However, residual metadata confirms the overload was not random interference. Signal rise time was smooth. Peak intensity plateaued briefly before purge. That shape resembles controlled transmission rather than explosive discharge. As we approach March 21, 2026, the calculated date of closest approach, global observatories are coordinating coverage. Radio arrays, optical telescopes, and infrared detectors are synchronized. Every pulse is recorded, every fluctuation logged. The official position remains cautious. Agencies describe the anomalies as under review. They emphasize the need for further analysis. Public briefings avoid definitive statements. But data does not require interpretation to exist. On February 23, 2026 at 8:42 UTC, 40 minutes of observation were erased during synchronized multi-instrument anomalies. A thermal spike of 360 degrees occurred without external heat source. Rotation halted and aligned toward L2. A directed microwave beam at 22.2 GHz overloaded sensors. A hydrogen line modulation at 1,420 MHz transmitted prime numbers. A 4,200 km trajectory deviation required 3.4 Gs of non-gravitational acceleration. The orbit changed from escape to capture at Earth's distance. These are recorded measurements, and the object is still approaching. As 3I Atlas continues inward, tracking precision improves. Distance reduces measurement uncertainty. The updated velocity vector confirms deceleration relative to solar escape speed. That alone is remarkable. Interstellar objects normally accelerate past the Sun, gaining speed as they exit. This object is doing the opposite. It is bleeding velocity. The geometric progression embedded in the recent signal pulses has been mapped against universal constants. Analysts note ratios corresponding to mathematical sequences used in orbital mechanics calculations. While not definitive proof of communication, the alignment between transmission intervals and its heliocentric velocity suggests synchronization. If synchronization exists, then emission timing is not random, it adapts. Observatories have increased sampling rates. The fine guidance sensor remains under special scrutiny in case further micro-vibrations occur. Engineers have reinforced buffer protocols to prevent another purge. Redundant receivers now record raw input prior to compression. The goal is simple. If another burst happens, nothing will be lost. Thermal imaging shows stable surface temperature near expected equilibrium given solar distance. No repeat spike has occurred since the blackout. That absence is notable. If the first event were natural, recurrence probability should rise as solar proximity increases. Instead, anomalies correlate with observation rather than environment. The density debate remains unresolved publicly, though internal models continue to favor a high-mass core. Gravitational interactions with minor bodies remain negligible, consistent with compact structure rather than diffuse ice. Radar reflectivity is lower than expected for metal, yet internal mass distribution calculations suggest otherwise. A layered composition remains possible. Volatile surface, dense interior. Such architecture would allow outward cometary appearance with structural resilience beneath. The hydrogen line pulses have intensified slightly in amplitude as distance decreases. Frequency remains stable at 1,420 MHz. That consistency is difficult to attribute to natural processes because stellar emissions at that line are typically broadband and diffuse. This remains narrowband and periodic. No confirmed artificial signature has been declared. Scientific caution persists. Extraordinary claims require extraordinary evidence, yet the cumulative anomalies form a coherent timeline. Detection, alignment, emission, blackout, trajectory shift, orbit capture, continued modulation. If intentional, the strategy is subtle. The object did not disable every instrument. It overloaded one critical channel while allowing another to record limited data. It moved during blindness but returned to observable state afterward. It did not flee. It repositioned. That behavior resembles neither aggression nor accident. It resembles controlled demonstration. The perihelion date approaches. March 21st, 2026 marks closest solar distance, nearly matching Earth's orbit at 1.01 AU. Whether Earth and 3I Atlas will share proximity simultaneously depends on orbital phasing, still under refinement. Current projections indicate no collision risk. Distance at nearest Earth approach remains safely beyond lunar orbit by substantial margin. But proximity is not the only concern. Data exchange potential increases as signal strength grows. If emissions intensify near perihelion, sensor defenses will be tested again. This time, redundancy should preserve continuity. The broader implication extends beyond one object. If 3I Atlas represents technology, then it implies capability far beyond current human engineering. Interstellar travel, structural integrity at extreme acceleration, adaptive signaling, these represent advanced mastery of physics. If it is natural, then our understanding of cometary behavior is incomplete at a fundamental level. Either outcome reshapes astrophysics, and we are days away from the most revealing moment. As the countdown to March 21st continues, the atmosphere within scientific networks is measured but focused. Data streams remain constant. Every observatory participating in the campaign understands the significance of uninterrupted monitoring. The previous blackout exposed vulnerability. This time, safeguards are in place. The geometric progression embedded in recent transmissions has become more complex. Analysts observe nested ratios consistent with logarithmic scaling. Whether coincidence or computation, the pattern persists. The hydrogen line carrier remains precise to within instrumental tolerance. No drift, no scatter. Trajectory models now show perihelion occurring almost exactly at 1.01 astronomical units. That near match to Earth's orbital radius continues to defy probability expectations for random capture. Orbital insertion without planetary assist remains the central anomaly. The deceleration profile suggests controlled thrust applied during the unseen interval. No secondary burns have been detected since. Surface observations reveal subtle reflective changes, though within error margins. No visible structural appendages, no exhaust signatures. If propulsion exists, it operates without conventional plume evidence detectable at current resolution. The scientific community remains divided between caution and concern. Some argue for unknown outgassing mechanics producing asymmetric thrust. Others note the lack of corresponding material ejection. Some propose rare electromagnetic interactions. Others emphasize the directed microwave emission as incompatible with spontaneous geology. No official declaration has labeled the object artificial. Yet documentation stands unchanged. On February 23, 2026, 40 minutes of observation were erased during synchronized anomalies across independent systems. A precise microwave beam at 22.2 GHz overloaded a primary instrument. A hydrogen line modulation transmitted prime numbers. A 4,200 km displacement required sustained non-gravitational acceleration. An escape trajectory converted into stable solar orbit near Earth's path. These measurements are not speculation, they are archived. Now, the focus shifts to what happens at closest approach. Increased solar radiation may alter surface activity, signal strength may peak, or nothing further may occur. Silence itself would be data. If emissions resume at perihelion, redundancy will capture full bandwidth. If trajectory adjusts again, deviation will be measured instantly. If no anomaly manifests, researchers will continue long-term monitoring as the object completes its first elliptical revolution around the sunday. The broader implications extend beyond this single event. Humanity has long searched for technosignatures, Dyson spheres, industrial spectra, megastructures. Perhaps we expected scale too grand. Perhaps subtle interaction with our instruments is the more efficient signal. For now, we remain observers. The clock advances toward March 21st. Deep Space Network dishes track continuously. Webb's instruments are recalibrated and reinforced. Gaia and ground arrays remain synchronized. Every byte is stored redundantly. Whether 3I Atlas proves to be exotic physics or engineered construct, the outcome will redefine understanding. Either nature is capable of phenomena we have never imagined, or intelligence beyond Earth has demonstrated awareness of our gaze. The rendezvous approaches. The data will decide. If you want real-time updates as this unfolds and deeper analysis of every new signal, subscribe now and stay with us, because the next transmission could change everything.